Howdy, AP PreCal. It is Miss Kosh. I want to revisit a problem that I did in last year's video. This is from Mr. Passwater's 213 Part 2, Example 5. I tweaked his work, gave him credit. I put on there, created by Mr. Passwater, adapted by me. It's my number 12, so it's the same problem as last year, but I have a better understanding of it, and I'm filming it. I'm recording on my iPad so that you can see desmos. So that's my intention here. So it's a log inequality problem, and it's gross. Okay, so let's jump in. And I think last year when I checked Mr. Passwater's answer key, it may not be his answer key, but whoever had posted an answer key on behalf of him, they had the wrong answer. But when I checked just now, they had matched what I have. Okay, so I feel better about that, but I want to show you a few things. So let's start this from scratch. So in this particular problem, we have a function g that's a natural log function and a function h, and we want to know ultimately when is g less than h. Okay, so in order for g of x to be less than h of x, then they both have to be valid. Okay, so any restrictions on g are no good for the whole situation. Any restrictions on h are no good. Okay, so the h is the easy one. When we look at this, we know that our x value has to be greater than, not or equal, greater than -4. Okay, because the natural log, you can't take the log or natural log or a log of any base of anything negative or 0. So when you plug in -4, you get natural log of 0. That's no good, but anything bigger than that is going to be good. Okay, so and then we need to look over here at this one. And when I see this natural log of x squared plus x plus 5, what I think of, okay, so I know I have a parabola, and it's opening up because this is positive right here. And I could either have it where it sits entirely above the x-axis, and when in that case anything I plug in would work, or it could be that that there's somewhere, oh that's funny, there's somewhere where it hits the x-axis, and so then I have, I'm sorry, that was not what I wanted to do. Where I have, because it's opening up, then I will have a situation where it gives me this piece would work and this piece would work, but the stuff in the middle would not, because that would be negative, and you can't take the natural log of a negative. Okay, so let me get rid of that really fast. Delete. Where is it? There it is. Oh, too much. Undo. How about we just erase? Okay, so sorry. Here we go. So when I looked at this, I thought, oh, well, does it factor? No, that's annoying. Is it easy to complete the square? No, that's annoying. So I, because it's easy to complete the square when this is an even number. It's not even. So I'm going to say x equals -b plus or minus the square root of b squared minus 4ac all over 2a. Okay, and so I get that x is equal to -1 plus or minus the square root of, this becomes a positive 20 plus 1 is 21 over 2. And so I have this value, because we know it opens up, that means we only want things, here are those two numbers, we only want things on the kind of on the outside. I don't know why I shaded like that. That was funny. I've never done that before. So it's an open circle here, because if we equaled that value, then it would equal 0, and that's no good. So we can double check by trying g of 0 is a natural log of -5. No good. Okay, that doesn't work for us. So so we know we want things that are smaller than -1 minus root 21 over 2, or bigger than -1 plus root 21 over 2. Okay, and we also need to compare that to -4. So and in addition to that, we have to set these two equations equal to figure out where they intersect. So then we can find where one is bigger than the other. So we're looking to see what's defined, and then where are they equal, and then I'm going to put everything on a number line and go from there. Okay, so this, if the natural log equals a natural log of something equals natural log of something, the somethings are equal. Usually I set it equal to 0, but I noticed that I have x and x and they cancel, so I'm going to go ahead and say x squared add 5 equals 9. Therefore, x equals plus or minus 3. Well, at least that number's nice. Okay, so we need to figure out roughly how big this value is. I know that root 21 is between 4 and 5 because 21 is bigger than 16 and smaller than 25. So if it's, say, let's look at the negative. If it's going to be more negative than negative 4. Okay, and so -1 minus, so this is going to be -1 minus something more negative than -4. Well, it's going to be at least -5/2. So -3, that was a little confusing. On my number line, I have a -4, I have a -1 minus root 21 over 2, and then I have a -3. Oh, and I'm making them all solid lines for no good reason. And then I have somewhere out there, well, I need a longer number line. What am I doing? Trying again. Okay. There we go. And then somewhere over here I have a +3, and then I have the -1 plus root 21 over 2. Okay. And so I know that this part over here, anything less than -4 is no good. So I'm going to say, you know what, just to be perfectly clear, I'm going to write out of domain. So that interval, it's not that it doesn't make a true statement over here, it's that I can't use it no matter what. That way I have the freedom and flexibility to change this mess if I wanted to. I don't know that I want to, but I have that freedom and flexibility. I also know that anything, oh no, you guys, I was wrong. Hang on just a second. What happens here is I just don't know how to compare my numbers. So if I let's look at this one, -1 plus root 21 over 2. Okay, root 21 is going to be bigger than 4, so -1 is going to be bigger than 3. 3 over 2 is 1/2. 3 over 2 is 1/2. And then that is going to be less than 3. So hang on, let me try that one more time for you. If I'm comparing this number to a +3, I know that the square root of 21 it can't be as big as 5. So a -1 plus 5 is going to be 4 over 2, which is 2. So this number has to be smaller than 2. So that means that the larger number is 3 and the smaller number is 1 plus root 21 over 2, and then that corresponds over here. So I apologize. You can tell me below where I start getting wrong, and now I fix it, so my bad. Like I say, I'm good, but not perfect. Okay, so here are where these things fall on the number line. We know not only is less than -4 out of the domain, anything between those two ugly radicals is out of the domain. So this interval right here is out of the domain. So now what I want to do is I want to check things. I have 4 intervals that I need to consider at this point. I have between -4 and 3. I have between -3 and this ugly radical. I have between this ugly radical, the new ugly radical, and +3. And then from 3 to infinity. So let's do the easy ones first. What I'm going to do is I'm going to look at g of -3/2. I'm going to change that to a fraction. That's g of -7 over 2. Okay, that becomes the natural log of 7 over 2 squared is 49 over 4 plus a -7 over 2, which is a 14 over 4, minus 20 over 4, so I have a common denominator. This is the natural log of 15 over 4. Okay, h of -3.5. I think that one's fine. Plug in -3.5 and we get the natural log of 1/2. I don't know why I put parentheses in one and not the other, but whatever. Okay, so what we have here is that our g value is going to be, g of x is going to be greater than h of x. Does that meet our requirement up here? No. Okay, so this gives me, maybe I would say here, this is a false statement. It's in the domain, but it doesn't make this statement right here true. Okay, so now let's try g of 4. that would be equal to the natural log of 16 plus 4 is 20 minus 5 is 15, natural log of 15. H of 4 is equal to the natural log of 8. Natural log of 15 is greater than the natural log of 8, which tells us that G of 4 is greater than H of 4. I don't know why I'm writing things differently this time. I guess you could do it either way. And do we want G to be greater than H? Nope. So this is also false. So our hope would therefore be that these other two intervals are the correct answer. And they are. It's just a little tricky to tell without a calculator. Because it's hard to know exactly what these values are. And so what would be, I think that if we tried plugging in 2.9, it's because 2.9 would be somewhere about here, and then like a negative 2.9 would be somewhere about here. I think that would work, but it's really kind of annoying. You know, if this showed up on multiple choice, I would probably be confident enough. I mean, maybe I would do more work, and I would be confident enough to pick that answer unless they had a no solution on there. I don't know. Okay, let's go look at, I mean, without a calculator, finding a value between those intervals is really kind of gross. There's just no way around that because we don't exactly know. Okay, let me pause and come to Desmos. So I typed these things in. So here's, oh, I should have labeled it. Was this first one? The first one was G of X, and I love using that on G of X. I love using that feature on Desmos where you label it, because then, and this other one was H of X equals, I need an equal sign. Okay, because then I can come down here and say, well, what is H of 2? And it tells me. I think that's nice to work with. I assume, well, we definitely need to spend some time practicing on the testing version of Desmos. I'm not sure what all they have, but there you go. Okay, so if I turn on this graph, well, notice I now have the decimal approximation for these guys. Okay, so negative 2.9 would have worked for that 2.9. Okay, let me see, hang on. This was about 1.8. Okay, so 2 would work, but it's hard to know that. And then this was a negative 2.8-ish. Was that what I just saw? I'm so sorry. You know, my kids are good at splitting the screen. I'm not. Here we go. Split. There. Yep, there we go. Oh, now I can't find what I need. Never mind. Sorry. Whatever. Okay, let's see if I can. There we go. There we go. Let's look at this. There. Okay. That's ridiculous. 1.8 and then a negative 2.8. Okay, so if this is a negative 2.8, is that what I said? It was. Okay. Then a negative 2.9 does work for us, but it's a little tricky. And then a positive 2 would have been another nicer value to use. So by hand, we can plug in G of 2 and H of 2. Let's see. G of 2 becomes 4 plus 2 is 6 minus 5 is 1 equals the natural log of 1. H of 2 equals the natural log of 6. Okay, so then H is greater than G. So this part right here is true. And that was easy to find once we figured out what our decimal approximations were. Okay, so back on Desmos. Okay, when I look at this, I can turn this graph on, and you'll notice, oh, hang on. Did you know this little home button over here takes you back to that main screen? It was on the right-hand side. I don't know if you can tell what I clicked. Okay, so here was that function, and we knew that it wasn't defined in the middle, and what's happening here is I have these two asymptotes right there, where it's approaching those. Those were that negative 1 plus root 21 and negative 1 minus root 21 all over 2. So that helps me figure out my domain. And then I also have this graph right here. So what I need is I need to know where is the blue greater than the red. Well, the blue, why aren't you working? Okay, the blue is greater than the red between this, the point of intersection there at negative 3, and this asymptote. That's this asymptote here, that negative 1. The negative 1 minus root 21 over 2. And then we have over here, the blue is greater than the red on this side. Between now the negative 1, this is this graph, not that, so that's that one. And then this point of intersection was at positive 3. So hopefully that helps you see this a little bit more. Not gonna lie, it's just tricky. But the good news is it will show up in multiple choice if it's on the AP exam. So hopefully once we were here, if it was this gross, even if we didn't know the true, I already knew that there were two intervals that it had to be, or it could be, or, well, what I don't know is if it's one of them or both of them or none at all. But I think an educated guess would include those the trick is trying to find the decimal approximations. But all right, like, subscribe, comment down below. Let me know how I can help you. And as always, go practice.